we have already talked about like analyzing the instructions execution in pipeline, which is called the multi-cycle diagram. So you see that um, when the first instruction is in the instruction memory or instruction fetch phase, when it is fetched, and in the next clock cycle when it is being decoded or the register files are read, the next instruction is in the instruction memory phase, which means that once the instruction is fetched, the new instruction is fetched, the previous data, previous instructions data, like what is the instruction, it will be overwritten by the new instruction. So we want to avoid this situation, because once what we want is all the stages should have the correct information about what instruction is being executed. Okay, so we need to ensure that all the information like this, if I go back here, you see, for example, if the LW instruction is fetched here, in the next clock cycle LW will be executing in this phase, and the next instruction, maybe add instruction, would be fetched from here. So once the add instruction is fetched, don't you think that add instruction will be placed here and it will override the data related to LW instruction? So we tend to lose the information regarding the LW instruction, all the control signals, whatever the register we are supposed to be reading or writing to. So what we need to do is to have some sort of like a storage element between each stage, so that we can store the information regarding the instruction related to the instruction. Okay, so registers are needed to hold the instruction information to be shared by other stages, and we must put register between each stage. So the updated pipeline architecture would look something like this. So all instruction advance during each clock cycle from one pipeline register to the next. Okay, so the registers are named for the two stages separated by that register. For example, the pipeline register between IF, this is the instruction fetch phase, and the instruction decode phase, it is named as IF/ID. Similarly, this one is the instruction decode phase, and this one is execution phase, so this register is named as IDX phase. Okay, so the PC can be thought of as a pipeline register, one that feeds the IF stage of the pipeline. Unlike the shaded pipeline register in this figure, the PC is part of the visible architectural state, which means that the memory and the register, all the storage elements like memory, register, as well as the PC are programmer visible, which means that the programmer can see, update, and retrieve the value of these registers or the memory. However, these shaded registers are not visible to programmer. So let me give you another example of like what do I mean by programmer visible or invisible register. So for example, if you have a thumb drive, you plug it into computer. After plugging into computer, you can see the folders in your thumb drive, and you can transfer the data from thumb drive to your computer or from your computer to thumb drive. Okay, so the folders that are visible to you are called the programmer visible, or simply you can see that these are the storage that you can move the data from one point to another point. But you never know. While transferring the data from thumb drive to computer, they might be storing it somewhere in between the intermediate registers or intermediate memory, which you do not have an access to and which is not visible to you. So this is what I meant to say, that these pipeline registers are not visible. They store the information related to any instruction as it is executing from one point to another, from one stage to another, but we do not have an access to that data. Okay.